All right, so we're on page 51. Notice how, if you look on page 51, the format looks very similar to what we were doing last week, where we have three of the same graphs. We're just looking at something different each time. And on Friday, we were specifically looking at where are we increasing, decreasing, and constant. And we were also looking at where the graph was above the x-axis, below the x-axis, on the x-axis, all those different characteristics we can identify. We're going to continue with some more characteristics today. Okay, just some different things you can look at in terms of a graph. So, just as a review again, if I said f of x or g of x, which variable am I referring to? Yeah, the y variable. Okay, so let's keep that in mind. If I told you f of x equals g of x, what must be true on the graph? Remember, f of x and g of x are the same thing as y. If f of x and g of x are exactly the same, what should you be looking for in terms of a picture or your graph? Can we think about it? Yeah, Marie, go ahead. A single line. Where they did you say overlap? Where they overlap, aka the mathematical phrase? Where they overlap? Intersect. Okay, so if the y value from the f graph is exactly the same as the y value from the g graph, they share that y value, aka point, in common. Okay, they're exactly the same. So if you share a point in common, that point is where they cross or intersect each other. So on the graph, we're looking for the intersection point. Does that make sense? Notice how if the y values are exactly the same, you must have that y value or point in common, okay, where they cross each other. What about if the f of x graph was greater than the g of x graph? Meaning the y value from the f graph is larger than the y value from the g graph. Yeah?
The y value from the f graph would be above the one from the g graph?
Okay, so graphically speaking, the f graph should be above or larger or greater than the g graph. So f of x is above the g of x graph in terms of your picture. Very similarly, if f of x is less than g of x, then the f of x graph is below the g of x graph. Do those translations make sense based off of this notation, f of x is less than g of x? We understand what it means? Okay, so interpreting what the notation means is half the battle. We're now going to try to identify graphically where these different characteristics are true or where they're happening. Now, we got to be careful though, because notice how now we're comparing two graphs together. Last week we were just looking at one graph. Where's that one graph increasing, decreasing, constant, above x-axis, below x-axis, on x-axis, okay? This time we're comparing two. So if we're comparing two, we have to make sure that we have the correct interval where those two graphs are in common, okay, where they kind of happen simultaneously. So when we go through these different characteristics, we have to be careful that we are aware of this interval where they're both showing up, okay, where both graphs exist. So if you take a look at one of the graphs down below, they're all the same, okay? Can you tell me the beginning x value where both graphs have a point, or kind of have a point, and can you give me the ending x value where both graphs have a point, or kind of have a point? Maybe they have an open circle. Okay, for instance, if you start on the left-hand side and you begin to trace your graph, when do you start kind of touching both pieces? Where are they both happening? Can you give me that beginning x value? Yeah. -4. Okay, now the question is, can you touch -4 on both graphs? No, right? Because you see that open circle at the top? So we would need a parenthesis. As you continue to drag your pencil, when do you stop touching both graphs? Go, Dylan. 7. Can you touch both graphs at 7?
Yeah.
Yes, there's 2 closed dots. Okay, so when we're going through these different intervals, we should only have values between -4 and possibly including 7. Okay, so that means this -5 point out here in that little line till -4 doesn't really mean anything. Okay, because we're just comparing both graphs. We have to look at when both graphs actually happen. Does that make sense? Okay. So let's go ahead and kind of label these graphs like we did yesterday, or last week. F of x is the dashed line, g of x is the solid line. If you have a marker, colored pencil, highlighter, let's go ahead and identify the different characteristics. The first graph is asking us where are the graphs exactly the same, aka their y values are exactly the same. So we're trying to find those intersection points. Maybe there's more than one. So go ahead and fill in or label those intersection points on your graph. Where does the solid line and the dashed line cross or touch each other? See, the next graph is asking us when is the F graph above the G graph in terms of your picture. So we got to look for when is the dashed line above the solid line. Can you label those sections? And then the last graph, we want to see when is the F graph below the G graph, meaning the dashed line is below the solid line. Can we find those sections? Are we okay? All right, so now that we identified them, or we labeled them, let's go ahead and actually write down mathematically where these points or intervals are occurring. So whenever you're labeling specific points, we're going to have exact x values, okay, like x equals 2, x equals 5, okay, where that point occurs. But if you notice on the second two graphs, we don't have exact points, we have an entire section or region. So the last two are where we're going to need those intervals, kind of the beginning point, ending point. So we'll get there in a second. Can we identify the x values of those intersection points? Can you find them on the graph? Good, Marie? Okay.
And then 5, 2.
There we go. All right, so she gave me the exact ordered pair, okay? If you want to just give the x value, that's okay too. Either one. All right, let's try the next one. So we're going to have intervals. Notice how we have 2 sections. So we should anticipate 2 intervals. Let's go ahead and maybe put that U in there because we're going to need 1 interval for the first section and then another interval for the second section. So as you drag your pencil from left to right, notice how the first interval starts at -4. And as you keep dragging, it ends at -2. But we got to figure out what are those grouping symbols. Are we using brackets, parentheses, mixture of both? So let's go ahead and check it out. So the question at hand is, does the point on the F graph, or is the point on the F graph above the point on the G graph? And we have to be careful, can you actually touch that point? Like, is there a closed circle there to include it? So this first point here at -4, clearly it's above the g-graph, right? Because it's in that interval. But can you touch -4? Yeah. No. So we're going to have that parenthesis. All right. Our ending point is -2. Is that location on the F graph above the G graph? Yeah. No. Did you see how we labeled that as an intersection point over here? Okay, that point is not above the G graph. It's actually on the G graph. They share that in common. So both of these have to have the parenthesis. The first one needs the parenthesis because it's an open circle. The second value of -2 needs a parenthesis because it does not answer the question at hand. Okay, is that point above the G graph? So parentheses kind of for two different reasons. All right, let's go ahead and try the next one. So we begin, looks like at 5, and it ends at 7. We got to make sure, do we answer the question at hand? Is there a point actually there to include? Okay, you need yes for both of those for a bracket. So it looks like at 5, isn't that another intersection point? Meaning the F graph is not above the G graph. They actually share that in common. So that would be a parenthesis. And then at 7, clearly that point at 7 is above the G graph. And we have a dot there closed in to actually include it. So that would need a bracket. Do you guys think you can try the next one? Okay. Looks like it's only one interval, so you don't need that U in there. Go ahead and identify the beginning value, ending value, and brackets or parentheses. Any takers? Give it a shot. Go to Maddie.
Parentheses, -2, 5, parentheses.
Love it. How'd you do? Good? Okay. So, on Friday, we were kind of discussing when do we need brackets, when do we need parentheses. When we were discussing increasing, decreasing constant, we always needed which type of grouping symbol? Do you remember which one it was? Just for increasing, decreasing, and constant? Were they all brackets or all parentheses? Do we need to look back? Yeah. They were all parentheses. Okay. But when we started talking about above x-axis, below x-axis, on x-axis, okay, those three characteristics, we started to get a mixture, depending on whether the question at hand was answered. And we're going to kind of have a mixture here as well, because you see how in this one case we had a bracket. So this is another case where you have to be careful about what is actually being asked. Okay, does that point satisfy the question at hand? So we're going to need a mixture, perhaps, of brackets and parentheses. So we'll say a mixture might be needed because how do you want to phrase the rest of it? Why do you think we would need a mixture? Yeah.
The points might not qualify.
Okay. Because the points may not qualify / answer the question. Okay, so very similar to that, above x-axis, below x-axis, on x-axis, same thing might happen here. You have to be careful, does the point actually answer or satisfy the question? Okay? Let's go back to domain and range because we're going to be coming into that in a few sections up here, or next week probably. Identify the domain and range of the following graphs. So maybe we'll do the F graph first. Okay, that's our dotted graph. Pick any of the three. Okay, I don't care if they're above each other, below each other, what the heck's going on. We just want to drag our pencil left and right to see what happens. So in terms of the dotted graph, looks like we start at -4. And there's an open circle, so we need that parenthesis. And as you keep dragging your pencil on the dotted graph, looks like it ends at 7. And there's a closed dot there, so we would need a bracket. Let's go ahead and now focus on the range. So going from low to high, start dragging your pencil. Looks like we start at -2. There's a closed dot there, so we can use a bracket. And as we keep dragging, what's our ending value on that interval? What do you think, Rebecca?
6.
6? How'd you get 6?
Well, there's always a point that satisfies that, even though there's an open circle.
Uh-huh.
-4, that x value. I mean, there's still points on the other side that satisfy that.
Exactly. Okay, so as you start dragging your pencil, some of you might get confused when you get to the 5 mark. Okay, because yes, there's an open circle here, but you are still touching a portion of your graph there, which means you keep dragging. As long as you're touching a portion, you're going to keep dragging until you don't touch something. And we don't stop touching the graph until we get to 6, which has a closed circle, so it'd be a bracket. Okay, so the range is always the difficult part when those holes start to come into play. As long as you're touching a piece, you're going to keep dragging that pencil. All right, let's go ahead and check out the G graph. So the solid one this time, left to right, looks like we go from -5 to 7. Both have closed circles, so both have brackets. And then low to high, we have -4 to +4, and both have closed circles, so both have brackets. Are we getting better with that domain and range? Graphically speaking, at least? All right, let's go ahead and check out another example on the back. So what's eventually going to happen is I'm going to give you a graph like at the top, and then just a bunch of different questions about the characteristics of this graph. For instance, we're going to take a look at 9 questions in this table. Okay, so looking at this F graph and G graph, they tell us F is the dashed line, so maybe we'll label that, and G of X is the solid line. For each indicated quantity, we are going to write in words, what are you being asked? And then once we have those words, we're going to identify the values or the intervals based off the way that graph is drawn. Okay, so let's take a look at our first one. Find the value or values of x such that f of x equals 0. What is that notation asking us to identify or find or locate on the graph? Can we think about, yeah.
Dashed lines, y values equals 0.
Okay, so dashed lines, y values are 0. Okay, literally that's what the notation means. And let's take that meaning and relate it to a graph. So if you have a y value of 0, where are you located? Where should we be looking? Yeah. The x-intercepts. Okay, so we're looking for x-intercepts of the f of x graph. So Rebecca said y values are 0 on the dashed graph. So take a look at your dashed graph, and where do we have x-intercepts? Can we identify those locations? Go ahead, Ashlyn. We got 1, okay. Any other ones? Yes. Go ahead. It looks like 19, maybe. Okay, be careful with those arrows, right? That means the graph is going to keep going. And imagine if we did have more graph, wouldn't that dotted line eventually cross the x-axis? Okay, so we do have another point that we should be able to identify. Marie thinks it's going to be around 19. Okay, let's try to figure out how accurate or how close she was. So in order for us to continue or extrapolate, okay, go into the future kind of that line, let's see if we can figure out the equation of that line. Can we identify the slope? Can we maybe think about where the y-intercept would be? Pick two really good points and then do rise over run. Yeah. 1/2, okay. And if you were to extend it, this one's a little tricky, right? Okay. What you could do is you could continue the slope in the other direction, down 1, right 2. And if we went another down 1, left 2, that would be at the -8 height for this point. So it looks like the y-intercept would be somewhere between -7 and -8. We'll do -7.5, somewhere in there. Can be a little tricky. So if this is the equation of that dashed line, we need to somehow figure out when the y value is 0, what is the x value. So if we were to add over the 7.5 and then bring over the 1/2 by multiplying by 2, if you double 7.5, what do we have? 15, right? Okay. So Marie, you were close. 19 was a good guess, but it's actually going to be 15.
I misread that. I thought that was 18. That's why I said.
Oh, that number on the end was 18? Yeah.
It's 13.
Again, the numbers might be a little tricky with the way it copied. You might have to count. Okay. So we actually have two x-intercepts. One of them was actually on the graph. The other one we had to figure out. Be careful with those arrows. Okay. Very similar question here. This time we're looking when g of x equals 0. So we would need to figure out the x-intercepts of the g graph. So now we're only looking at the solid graph. Can we pinpoint any x-intercepts? Go ahead, Marie.
In between -4 and -5.
Okay.
Again at 5. And then in between 10 and 11.
Okay, so we're not quite sure what that x-intercept is. Maybe we'll guess -4.5. Okay, I'm okay with approximations. Looks like the next one, though, is exactly 6, so that's nice. And then the next one between 10 and 11 will approximate 10.5. We're doing okay? All right, let's try the next one. What is this notation asking you to find or identify? F of x equals g of x. Yeah. The intersection points. Okay, so in terms of the solid line and the dashed line, we want to figure out just the x location. If you want to give the actual ordered pair coordinate, that's okay as well, but just in terms of the x-axis, what are those locations where they cross each other or touch each other? It looks like we have 2 points. Can we determine those x values? Maybe roughly where they are? Yeah.
The one that's kind of like
Negative 1/3, okay, -1/4, 0.25, something like that. Okay, an approximation. So maybe we'll go -1/3. That's okay. I mean, if we wanted to, we could be really exact, right? We could figure out the equation of the solid line at that point and the equation of the dotted line at that point. We could set them equal to each other and figure out the x value, but that would take us some time, right? We could. I know we could. But for time purposes, we'll just go with that approximation. Looks like the other intersection point is 9. All right, let's check out our next one. The values of x such that f of x is less than g of x. What are we trying to find graphically? What's that notation asking us to do? Yeah. All right, dotted line f of x is below solid line g of x. So we'll say f of x is below g of x. All right. So take your pencil, highlighter, colored pencil, marker, whatever you want, okay, at least for this question. If you're using a pencil, maybe you just want to bold it to help you out. We want to figure out where's the dotted line below the solid line. So looks like we have that section. Yeah. Yeah. Okay, so take a look. This point right here, that intersection point that Marie's bringing up, that point's kind of special, right? Because if you were to trace that dotted line that I colored blue, and you were to eventually get to that intersection point, is that point on the dotted line below the solid line? If it's an intersection, aren't they on each other at that point? So we really have two intervals here. I know it looks like one, but we really have two, because the first interval starts at this intersection point and goes to the other one, but we kind of have to skip over that point because it technically doesn't answer the question. Okay, this point on the dotted line is not below the solid line, and we're going to have to think about that other interval afterwards. So we do have two intervals. All right, so let's talk about the first one. If you were to drag your pencil, looks like we would start at that first intersection point, which we said was a -1/3 value. And as we continue to drag our pencil, we get to the other intersection point, which we said was 9. If those are the intersection points, that's where the graphs are exactly the same. But we are trying to figure out where is the dotted graph strictly below the solid graph. Okay, not where they are the same or touching each other. So both of these would happen to be parentheses. If we keep dragging our pencil though, we're going to pick up again at that 9 intersection point. Where's this interval going to end? Yeah. 17? How'd you get 17?
Because if you continue the line, eventually you can guess that it would be around 117 and the other graph ends at 1, or does it not count for the stop?
Oh, you mean this one? That's 11, honey. Is that what you're talking about? Did you mean 11 instead of 17?
Yeah, sorry.
That's okay. Perfect. Okay, so notice how the blue dotted line would continue forever, right? Okay, but if we only want the section where the dotted line is below the solid line, notice how the solid line ends at 11. So anything after that is irrelevant because there is no solid graph to compare it to. So it looks like we can end the comparison at 11. Does that make sense? Okay, remember how we discussed before, you can only compare two graphs where both of those graphs are happening. And if the solid line stops at 11, that's where you have to stop your comparison, because then you only have one graph after that instead of two. So in terms of answering the question, is this point on the solid graph below or sorry, is this point on the dotted graph below the solid graph? No, because they're intersecting there, right? They're exactly the same. So that 9 would need a parenthesis. This ending location of 11 is that point on the solid graph, I'm sorry, the dotted graph, below the solid graph. Yes. So that would be a bracket. There's that mixture again that we got to be careful of. All right, these are going to take some practice. Let's go ahead and try the next one. So we want f of x is greater than g of x. What's that notation asking us to identify in words? Good, Maddie? F of x is above g of x. Okay, so this time dotted line is above solid line. Can we trace that section? Now we know that the dotted line is going to continue forever on the right-hand side, but again, if you're comparing two graphs, you can only compare where both of them happen. And if the solid one is ending at 11, notice how when the dotted line eventually does get higher than the solid line, that's not going to matter because we have no more solid line to compare it to. So it looks like this is the only section we have to identify. So if you drag your pencil, looks like we start at -9 and then go to that intersection point. We labeled that before as -1/3. So that x value at -9, can we touch that point? No. Okay, I know it's technically above the solid line. Okay, that's true, but there's actually no point there to touch. So we're going to need that parenthesis. And then when we get to the intersection point, that particular case is not answering the question because we want strictly points that are above the solid line. This is a point that is on both the solid and dotted line, so we would need another parenthesis there. Are we starting to get the hang of these a little bit? The trickiest part is the bracket or parenthesis. Okay, does that point satisfy the question at hand? And is there a point there? All right, what about the next one? F of x is greater than 0. What are we trying to find? Yeah. Above 0. So above 0 means above the x-axis. If we're looking at y values above 0, those are all positive, and all the positive values for y are above the x-axis. So only looking at the dotted graph. We don't care about the solid one. Only looking at the dotted graph. Where is that above the x-axis? Maybe you can trace it. Can we identify that interval? Looks like we start at -9 and go to 1. Can we figure out bracket or parenthesis on that -9? You got to ask yourself two questions. Are we above the x-axis? Is there a point actually there? You have to answer yes to both of those. Yeah. It would be a parenthesis. Good. Okay. And then same two questions at 1. Are we actually above the x-axis there? Is there a point there to count? Yeah. It'd be another parenthesis. Okay, this time for the opposite reason. Okay, we do have a point there. Okay, you could put a closed circle there if you wanted to, but it is not above the x-axis. It's on the x-axis. So notice how these are both parentheses, but for different reasons. Is that it? Is that the only section where the dotted line is above the x-axis? Remember, we don't care about the solid anymore. Anthony, you're shaking your head. Where's there another one? Okay, so we have that arrow on the end, right? This would continue forever, so that means that it's eventually going to be above the x-axis, right? Okay, and we said that the x-intercept before was at 15. Okay, that was actually in the first block we answered. So from 15 to infinity, we're going to have another interval. So we got to ask ourselves the same two questions. At 15, are you above the x-axis? No. You are actually on the x-axis, so that would automatically be a parenthesis. And then if you were to go out towards infinity, are you above the x-axis at that location? Yes. But is there a point at infinity? Can you ever reach infinity? No. So that would be another parenthesis as well. Okay? Be careful with those arrows. There might be some hidden sections. Are we doing okay? Do you guys want to try the next one on your own, maybe? All right, take a look at the next one. G of x is increasing. So in words, how can you describe maybe graphically what's going on? What should you be looking for on that picture? Yeah. Positive slope. Okay, so g of x is the solid line. G of x has a positive slope. In other words, if you trace your graph from left to right, the graph is going up. Okay, positive slope. So go ahead, maybe take a look at the solid graph, solid line. If you were to trace it left to right, where would you be going up? Looks like we have two intervals. Any takers? What do you think, Rebecca?
I would want to say -6.
Uh-huh.
2, and then I just like the U thing,
Yep.
and then 9. Oh, wait, would it be 3?
It would be 3. Yep.
Oh, sorry.
It's okay.
I didn't see the thing. And then 9, and then 11, with both parentheses.
With both parentheses. Okay, increasing, decreasing, and constant. Those are always those parenthesis grouping symbols, okay? Because if you are traveling, think about going up, going down, or constant, okay? These ending points represent either beginning and stopping points or changes in direction, which you are not moving up, down, or constant at those locations. So these should always be parentheses. Maybe you guys can go on and do decreasing and constant. If g of x is decreasing, it has a negative slope. So when you trace it left to right, your pencil or finger or whatever you're using goes down. And if g of x is constant, can we relate that back to slope? If you have a constant graph, what's your slope value? Yeah. It is 0. Has a slope of 0. Okay? But again, in terms of tracing, if you're constant, your finger or pencil is going to be flat. So go ahead and try to find those sections on your graph, where your graph is going down and where your G graph is flat. 3 and 9 sound good for decreasing? Remember, we're looking at the solid graph. And then what about negative 11 to negative 6 for constant? All right, we hanging in there? So far, so good? Okay. All right, so we're going to end there for today. Notice how tomorrow, okay, we're going to have another example. I think it's the same graph. We're just going to be looking at different characteristics that we can identify. This is not going to take us all period tomorrow, so whatever time we have remaining, I'll let you go ahead and get started on the homework for this section, okay?